Welcome everyone. I am John Ellis and I am hosting today's webinar, Programming Provoking Poetry, with my good friend Paul Lynham, who I've known for nearly 30 years, and we only found out in recent years we have very similar backgrounds in that we both came from farming backgrounds and went into computing. In addition, Paul has been a lecturer for Pencoed and Bridgend colleges and for the Open University. In the 1980s, Paul was developing software for various vertical markets, including farming. In 1997, Paul was persuaded, more mugged, to join the IAP Council by Mike Ryan, the then Director General, and has been a steadfast supporter of the institution and its members. In 2011, he became Director of Member Engagement, and in 2018 he became President. In recent years, Paul has taken up writing poetry, with 6 books now published. So I'll hand over to Paul for his presentation on Programming Provoking Poetry.
Lovely. Thank you, John. Thank you for that lovely introduction. I hope everybody can see the screen okay. What I wanted to do with this, it's just a tool really, like a clothes horse to hang something off, because I wanted to talk about different aspects of software development. In the amount of time that we got, I can't go into much depth, but there will be a chance to ask some questions at the end. So it's just a matter of I'm going to read a poem, and then I'll look at some of the concepts. I've highlighted the words when I put the poem up on the screen, and then I'll go through some of the concepts and what comes from them, and I'll just repeat that for the 3 poems we're going to have a look at, and then I'll summarize it, and then at the end I'll open it up for questions and discussions. So this first one that we look at is a book from my first collection of poems called Carter Poems, and it's called The Pensiveness of Coding. And before I start, I just want to let you know, perhaps you may not be aware, but a gavotte, you may be wondering what a gavotte is. Well, it was a sort of an 18th century French dance, but it's also music that is used to the rhythm of the dance. So you can think of it as a beat in this context. So I'll just read the poem, and then I'll go through some of the concepts. The pensiveness of coding, we in ethereal options. At the computer, thinking relentlessly, ideas appearing and then receding, tested for fidelity, avoiding entropy, quietly believing the quest for flexibility will take some conceiving. Like trains in the tube station, these ideas come and go, waited for an inspired solution, but keeping up the flow. Yes, but no, that won't work. Will the answer ever show? First a light beam scout, and then the trains cease, and the thoughts flow out like the passenger's apogee. The journey's end, no doubt. Now press the tab key. A virtual blacksmith, now you're in the groove. Creative juices to a gavotte. Simplicity will improve, but while the iron is hot, strike the keyboard rendezvous. A masterpiece you've wrote, or a Gordian knot? So we'll have a look at some of those highlighted words. So we'll have a look at what is fidelity, flexibility, entropy, simplicity, and a Gordian knot, and what's their relevance to producing software. Fidelity. So the dictionary definition is an exact correspondence with fact or with a given quality, condition, or event, or its accuracy. And an example is the fidelity of the movie to the book. And quite often you've seen movies, and if you've read the book before, you'll often compare the book to the movie. Did the movie, was it reflected in well by what was in the book? So, some of the things that I just want to briefly talk about are user requirements. We often call these functional requirements. And quite often they set out in a document. Some different organizations have different names, but quite often it's called a software specification document, an SSD. And one of the things I want to give you just a quick insight is sometimes do the users know what they really want? And then I'll look at non-functional requirements and what the architectural considerations are. So the first thing I will do is I'll give you a bit of an example. So quite often you've got this, what we call the iron triangle, which is the three competing things that are involved with software, which are scope. In other words, what are you going to deliver, the functionality, you've got the cost of it, and you've got the time. And quite often, if you change one, you've got to change either one or the other, or more often than not, both. So for example, if you want to increase the scope of the project, it'll most probably increase the cost and it may increase the time. If you don't want to increase the time, you've got to take on more resource to do it in the same amount of time. So that's going to cost you more. So there's this iron triangle involved, and in the middle is quality. So that's linked to fidelity, because fidelity really is how accurate it is to the specification. And I'll give you an example. Say now you need to build a road from A to B across country. One of the things that you could do is you could remove the soil until you come down to uncompressible soil, and then you could fill it with gravel and roll it, compress it to make sure that it's not going to move. And now you've got a road. The road, it's okay, it's not the best quality road, but it will certainly work. However, by trying the road, you may notice that if you brake hard or you go round corners too quickly, you'll find that the car skids. And that's because the surface is still a little bit loose. So what you could do is you could go on to the next iteration and think, right, we'll put a slab of concrete on top of it. And the thing is, with concrete, it does expand. So, every so often, every, say, 20 feet, you've got to put an expansion joint in there. And naturally, as its nature, concrete is noisy. So you drive along this concrete road now and you notice that it's very, very noisy. Great. It's great when you stop, you can put your foot in the brake and you're not going to skid like you're on the previous track. And the same with cornering. If you go around the corner, it's going to grip better, but it's still not the best quality. And the best quality would be to cover it, put curbstones in, and then cover it with tarmac. And then you've got the third iteration, which is higher quality. You'll notice that, especially if you've got a good car, quite often if you've got a good car, the only noise you'll hear is tire noise. And if you've got a very good car, you won't even hear that. But so each one of those iterations gives you the requirements, but it goes up a level. And quite often you're put in this situation when you work into a set of specifications. At what level of fidelity do you go along? And as I said, do the users really know what they want? In Agile, quite often you can get around this problem because at the end of each sprint, you can do what we call a show and tell, and you can expose it to the users or their representatives, and they can say, right, we hadn't thought about that, and then you can change the specification. Now, non-functional requirements it could be that sound is one of them, that you hadn't thought about sound, but the person who's designed it really ought to think about these things. And with architectural considerations, you think about the abilities of software. So, for example, you think about what it does now and how it could evolve in the future. So you'd think about its maintainability and how good it is, how it's going to scale up. So those are things that you need to consider. I'm just quickly going on. It pains me to do this, but I can't obviously spend the time going into depth into this. So the next one, that when you're thinking about writing some code, you think about entropy. Well, the definition is the amount of order or lack of order in a system. Now, when you apply this to software, it's the deterioration of software quality or performance over time, and that could lead to it to becoming faulty or unusable. So the things I want to just quickly cover are technical debt, what a code smells, the Boy Scout rule, and refactoring. So technical debt is where you don't let the software be at its best. So you keep on adding things to the software, and instead of reviewing it and thinking, we could rewrite this, or we could do it in a different way, which would make it better. If you see, for example, lots of comments in code, that could be an example of a code smell, because it's complicated. It could be that it's poorly understood. There could be some caveats. So quite often it's worth looking at commented code and seeing if you can make it simpler. The Boy Scout rule is all about when you touch code, you should try to make it better. It's a bit like the Boy Scouts who go out on a hike. They may take plastic with them or cardboard or tins, but they always take it away with them. And if they see any rubbish, again, they'll pick it up and take it away with them. So that can be applied to whenever you touch code. And the last one there, refactoring, is where you can put aside some time and think, this stuff has been changed so much now, it's not really good. What we need to do is we need to refactor this particular module or class or whatever, make it better, keep it say flexible. So one of the things that come out of this is a principle called the open close principle. It was a chap called Bertrand Meyer who wrote a programming language called Eiffel, and this principle says that software entities such as classes, functions, and modules should be open for extension but closed for modification. Now, that may not make a lot of sense when you first read it, but think of it like this. If you are doing, say, for example, OO programming, and you write a base class which encapsulates all the commonality of an entity, then you should write it in a way that once you've done that, you should try not to do anything further to it. You can now inherit from it, and that will allow you to extend it, but you don't want to go back to the base class and keep on messing about with that. And this principle is one of the what we call the solid principles. And there they are up on the screen. Single responsibility. The open closed method is the second one. The Liskov substitution, interface segregation, and dependency inversion. And I'm going to talk about dependency inversion a bit later on. So the next one was flexibility. So that's the ability to change or be changed easily according to the situation. Now, as you know, in any IT environment, it's often changing and changing quickly. So when we look at something, we often need to have the mind to what's going to happen in the future, so we can quickly adapt to new or changing requirements, because what we want to do is avoid brittleness. as software gets older, the entropy gets greater, it becomes more brittle, so it's easy to break and it's hard to change. And the other things that we ought to think about are a decoupling, which means that you don't want to be dependent on lots of other software, whether they're your own software or third-party software. And you often see this in what we call cross-cutting concerns, which is something that comes out of aspect oriented programming. So cross-cutting concerns are where you're using security or you're using login. For example, you may want to have logs. We used to call them asserts years ago, but they've been developed into sort of login libraries. You may have heard, for example, log4j, which is quite a common one, and it's where years ago, if you were using BASIC, you used to put like print statements in your code. So as it went along, you could see what was happening. I mean, today we've got fantastic development environments where you can put breakpoints in, you can look at variables, their values, you can even change the values. So we're much more complicated than that. But these logs are quite often good for when you deploy the software. When you first deploy it, you may want to see how the software is running. But of course, you're tying in all your classes may be tied in to this login library, and you really don't want to do that. Single responsibility, going back to solid. So what you can do is you can think about trying to isolate it in one place. And there are certain libraries around. Spring is the one that I've done a little bit with, both Delphi and Java. And the Spring framework gives you some opportunities of doing different things. It's got built-in login as it is, but say you was doing some security. Should the current user be able to execute this function? Well, instead of putting code in the actual function and saying if the user's got these privileges, then allow it to happen, or exit if it doesn't. You don't want to do that. So what you can do, for example, with Spring is you can do method interception. So as soon as it hits that function, it goes off. You've tagged it for method interception, and then it'll go. You can put it in a different module, and you can then do your check in there. So your original code is untouched. It's not being polluted by, a third-party library. Inversion of control. It was a big topic about 20 years ago, and it's still there. And dependency injection. Think of inversion of control in days gone by when you were procedural programming. You controlled what was happening in modern environments. The sort of you've got to react to different events, a mouse movement, a mouse click, or whatever. So it's like, instead of the dog wagging the tail wags the dog. So you can have frameworks where most of the day-to-day stuff is done by the framework, and then you can say what happens when an event happens. This type of event, what am I going to do? And dependency injection is where, instead of going back to the cross-cutting thing, it's almost like that. Instead of compiling things in like a third-party piece of code, when you compile a program, you decide, even at runtime, what is going to be used. So you can build up a container. You've got to comply with an interface. So the interface, this is gives you an example. You've got a feature that relies on a concrete class. Now that's stuck there forever. You should be refactoring out, so you actually program to an interface. So the feature can call the interface, and you've got a container of classes that match that interface, and at runtime, or by configuration, whatever, you can decide which of those concrete classes are going to be used in the implementation. Lastly, on this one, we're going to look at simplicity, which is a property, condition, or quality of being simple or uncombined. The fact that something is easy to understand or do. Certainly when you're writing code, you want to keep it as simple as possible. And that is often very difficult to do. It's much easier said than done. So we have this key word, KISS, keep it simple, stupid. It's always better to start off that way. That's the ideal. Quite often it gets away from you, but you need to come back to it again. You've heard the saying, less is more. If you can express something simply, you'll get more from it. And if you do something complicated, you may not understand it all. And Albert Einstein said everything should be made as simple as possible, but not simpler. I've quoted that, but I don't fully understand that myself. I've often thought about it. How can it be as simple as possible, but not any simpler? But Edgar Dijkstra, who was a fantastic, he was a Dutch computer scientist. He came out with a fantastic paper called Go To Considered Dangerous. He said simplicity is a prerequisite for reliability. Now, if you're a Python programmer, you'll most probably know the Zen of Python. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. And complex is better than complicated. Flat is better than nested. Sparse is better than dense. And readability counts. And I'll just finish up with that point with this concept of a Gordian knot. You may not have come across this term, but it's from ancient Greek mythology. I assume it's mythology, but it could there may be some fact in it. There were some Phrygians, and they were without a king, but an oracle said that the next man to enter the city driving an ox cart should become their king. So a peasant farmer named Gordius drove into the town on an ox cart and was immediately proclaimed king. And he tied up the ox cart to a post with an intricate knot. I suppose he was worried about somebody stealing it. And the knot was later described by a Roman historian. I often take this type of stuff with a pinch of salt, Quintus Curtius Rufus, as comprising several knots, all so tightly entangled that it was impossible to see how they were fastened. So this term Gordian knot is used today to describe a complicated problem. It's hard to decipher, and according to the legend, Alexander the Great used his sword to slice through it because it was impossible for him to see how to untangle it. So when you're producing software, you don't want to produce a Gordian knot. So the antithesis of this is simplicity. Otherwise, it'll be hard to understand, it'll be hard to change, and it's hard to be completely confident that the changes will work in every event. Now, so my the second point we're going to have a look at, it works on my computer, and this is from a book of mine called Patterns Revealed. And this one is not quite as much of a problem as it used to be. But I'll read the poem and we'll have a look at these highlighted concepts. It works on my computer. I don't understand where you're coming from. It always works fine on my machine. Its configuration as a rule of thumb. The right result is shown on my screen. It can't be my coding as it's flawless. You'll never find a bug in my code. I'd shudder if that should ever befall us. Maybe a virus in the payload? To your opinion, you've an entitlement, but to question my skill is absurd. It's most likely to be your environment. Faults in my code have never been heard. To start off with, try reinstalling the program, and after, reboot the computer. If you discover you're still getting smoked ham, then it's sure to be the transmitter. If the behavior is still unexpected, a coding fault is enticing, but that conclusion must strongly be rejected, as without doubt, it's a Heisenberg. With your firm insistence, I'm growing bored, and my patience is getting rarer. You will have to go back to the drawing board. The requirements must be in error. So I've picked out 3 things to look at here: rule of thumb, your environment, and a Heisenberg. So rule of thumb, well, the dictionary definition is a general guideline rather than a strict rule, an approximate measure or a means of reckoning based on experience or common knowledge. Now, programming is a practical undertaking, and sometimes theory and practice doesn't always line up. And there's been for many years this sort of debate about whether it's a craft or whether it's engineering or whether it's art or if it's science. And quite often you will find that it's a mixture of all these things. Sometimes you've got to trust your own insight, but if you do that, you've also got to verify it. So you can use this, think of this to remember: trust but verify. And apparently that was a Russian proverb that was adapted by Ronald Reagan. I'll give you an example of this. You may find that the performance of the software is not as good as you had hoped, and you think, oh, I got a feeling the bottleneck is at this particular place. And you could go ahead and you could alter that piece of code and make it more streamlined or whatever. And then you run the software and you find it hasn't made a slightest bit of difference. So you should, before trying these things, you should also verify. And again, you can use login, or you can use special programs that you can look at different parts of it, and you could do time in between them. And you can, by using this, you can find out exactly where the bottleneck is. There's also a thing called it's a problem, a classic problem in computing called P versus NP problem, which I don't want to go too deep into this, but basically it means that something can be very hard to solve, but it can be checked very quickly. I'll give you an example. If any of you do Sudoku, you normally have a grid of 9 rows, 9 columns, and there's the number 1 to 9 has got to be in every row and every column, but only once. Now, can you imagine if you had this a million, from 1 to a million, a grid like that? And you normally fill it in to start off with. They give you a very basic temp. Depends on the ease of it. You can get very easy ones which are mostly filled out, or very hard ones which got very few numbers in them to start off. But you've got to make sure that you put a number in more than once, that in a row or a column. So you can imagine if you're trying to solve this problem, it'd be quite difficult to solve, but it's real easy to, if you're given the solution, to check. That's all you've got to do with every row, is go through the first row and make sure that the numbers from 1 to a million, each number only occurs once. And you do that with the next row and the next row and the next row until you go through all the rows. And you do the same then with the columns. Okay, and with a modern computer, you could most probably do that in a second or two. So it's very, very quick to check, but it's very, very difficult to solve. So they are those type of problems. And the last one is the 80-20 rule, and you most probably come across this several times. So an example may be 20% of your effort gets you 80% of your results. And then the other 80% of your effort only gives you 20% of your results. And I've heard it saying with software that 80% of your users only use 20% of your features, and 80% and 20% of users will use 80% of your features. So you've got this 80-20 rule as a rule of thumb. So bear some of this in mind when you're doing some of this stuff. You may only need to get to 80%, so you may only need to expend your 20% of effort. Now, in the poem, we said as a rule of thumb is it's your configuration. So I'm going to have a look at your environment, and this can refer to either your working environment or the configuration of your development machines. Your working environment, there's all sorts of features. So I've picked out two. Of the organization you're working for, the culture and the leadership are extremely important. And it doesn't matter how good you are, what good ideas you've got, what practices are, if it's stymied by the culture or the leadership of the organization, that can really put a massive burden on you, and you might not be able to get what you want done. And quite often it's a reason why people leave. And then other things like whether you've got an open plan office or you've got your own office, or whether you're working from home, all these factors. There's lots of factors in the working environment that affects productivity. And then your development environment, that's your platform, which is your hardware, your software, your OS, and your tools, the configurations, and the use of build engines, and then say using virtual machines to test. So years ago, there could be all sorts of problems where you didn't have these build engines. You may have had scripts, but these days Jenkins is one that a lot of people use, and from the repository, or even going back to that to planning, you may have some sort of Kanban software where you can put up your features. You can drag things out from your backlog into the current sprint. You can tie changes, feature changes into the repository. You can get your code reviewed. You can put your tests in. You can get it then to run. You can spin up a virtual machine and have your software deployed, and it'll run the tests. And this is a much better way of making sure that this software is not just being run on your computer. Because I've heard this so many times when a tester or a user comes to a developer and says it doesn't work, and they'll say it works on my computer, but that's not the point, is it? It's got to work on the target computer. So these days, DevOps are great in supporting this. I've worked in organizations that have had great DevOps teams, and they've been a real bonus to your productivity. And a Heisenbug, just a bit of a bit of lightness. A Heisenbug is a software bug that seems to change its behavior or disappear when one attempts to study or debug it. And this term is inspired by the Heisenberg uncertainty principle in quantum mechanics, which state that the observation of a certain quantities can disrupt their value. If you look at subatomic particles, you can either see where they are or what their speed is, but you can't find out both. By reading one, you affect the other one. So Heisenbugs are often caused by issues like memory corruption, compiler optimizations, or race conditions. And these can be very difficult to debug. So again, looking at just two things, there's more to it than this, but static analysis. Now, static analysis, debugging happens when the software's running. Static analysis looks at the code when it's not running. So you normally have a tool to do this. So it'll look through your code and it'll come up with hints, or it'll find errors. For example, you may have used a variable without first initializing it. They're quite often things. I mean, certain languages won't allow you to do it, but with other languages which are more flexible, you could actually you can even define variables on the fly and use it straight away, and it doesn't know what the initial value is. And then code reviews. There's all types of different kinds of code reviews, but it's always good code reviews. In other words, reviewing the code that's been written by at least one other person. This is better than debugging. It gets you much better results. You'll find much more errors in software with code reviews than what you will via testing, believe it or not. So Heisenbug is fuzzy and difficult to find and fix, whereas a Bohr bug is solid and can be easy to recognize and fix. There's all sorts of funny names for bugs. There's Mandel bugs after Mandelbrot sets and so on. But a Heisenbug is, you don't want to get those. So the last poem is called Rubber Ducking with a Cardboard Guru. And if you're not familiar with either of those terms, rubber ducking or a cardboard guru, you may be wondering what this is about. Well, when you've got a problem, you've got a bug, you've tried everything that you can think of, and you still can't find that bug, you can ask a colleague to help. So you may start to describe the problem to them. You lay out the background, you tell them some of the steps you've taken, or you may actually sit down with them and you start to demonstrate the code. You may run through it in a debugger, in fact. But during that time, you realize something that you've overlooked. And this will lead to the solution. It's often called the eureka moment or the aha event. So I'm just going to read this poem, and it's actually based on the structure of an owl and a pussycat. If you know that poem. Rubber ducking with a cardboard guru, debugging software. The developer sought the buried bug, rummaging through the source code. Managing a shrug, he slurped from his mug, so a painful expression showed. He stared up at the ceiling above and cursed, not finding a thing. For the love of God, for God my love, please reveal to me something, something, something. Please reveal to me something. His logic was dim and his head in a spin. He couldn't see the wood for the trees. With this bug I've been parried. Too long have I tarried, said he. I've been brought to my knees. He thought for a bit and then had to admit some help was needed to proceed. So he went to a room, a social vacuum, to converse with a dummy indeed. Indeed, indeed, to converse with a dummy indeed. He stepped through his code so his angst could unload, explaining to the dummy aloud. As he described, in his mind he imbibed, and at once was lifted the shroud. His mood had shifted and his heart uplifted as he realized the root cause. How silly was I, he started to cry, because he could see what it was. Because he could see what it was. So why does this eureka moment or this aha effect come along? Well, this is actually a very interesting phenomenon, and that people have looked at it and they've come up with all sorts of ideas. But these are some of the reasons why this may happen. So you step back from your normal code writing frame of mind. You take a wider view of the problem. And in explaining this to your colleague, you slow down and you take small steps. You don't make any assumptions or skip over steps. And by coming out of that sort of internal deliberation you were in before, you get a change in the train of thought. And actually, the act of explaining may cause other stimuli. So you don't even need to do this with a colleague. Rubber ducking is the technique of debugging software by talking to an inanimate object, such as a rubber duck. This technique is also known as the cardboard guru effect, as you can explain the issues to a cardboard cutout of a real person or even a dummy, talking to them as though they are experts. Some software companies have a room containing only a dummy, where a software developer can go to discuss the issues they're experiencing with it. And in these type of organizations, you must try this first to prevent disturbing your colleagues unnecessarily. So I know it's been a bit of a rush to get through all these concepts, but here's a quick summary of what we've covered today in these poems. And all these poems I've put into a book called STEM Nuts and Bolts, Science, Technology, Engineering, Maths and Nature poems. So they're all to do with those type things. I've pulled them out from my sort of like 6 other books. So the concepts that we need to bear in mind while programming are: keep things true to the specification, making them simple and flexible. The level of the specification, some people love to do what they called gold plating. You may have heard of that term, where you add all the bells and whistles, but quite often, especially if you're agile programming, that's not a good idea, because once you do your next show and tell, and the users may say, no, we don't want it that way, and you've got to change it. So you've wasted all your time. So, if you're going to do anything like that, that's got to be at the end, and it's got to be part of the specification. However, bear in mind that software is not purely engineering. Sometimes we have to make a judgment call, but where possible, verify this. So trust is good, control is better. So it's always better to be informed. It's good to have experience. It's good to have a gut feeling, but where possible, try to get some metrics. And the aim is to keep code well structured and pleasing to read. And we don't want code to be a Gordian knot. The problem of code working on your machine but not on the target or test machine is that's not such a program as it was, especially if we can use sort of automation and build engines and deployment engines, and you can use a thing called observation. There's all sorts of software you can stick in your program these days to check things out as it's running. However, if you come across a Heisenberg, that can be very difficult to pinpoint and to debug. And when you're having troubles with bugs, try the cardboard guru effect. You never know, it may work. So we're open now for questions and discussion. Anybody got any questions?
I was sorry, I put my hand up. So Paul, for your inspiration, do you think of a particular computing problem and then think, right, I'll write a poem around this, or is your creative process a different one?
it can happen in several different ways, Martin. And sometimes sometimes you can sit down and you can force yourself to write a poem, but quite often you'll throw it away because it's rubbish. It comes in the most strangest of places. On a Sunday morning, I often relax in a bath and listen to podcasts or an audiobook. And while listening to an audiobook, for example, you might have thoughts about something, and I've got a sound recorder on my mobile phone. I'll just I'll say some notes, and later I might come back to those and then write a poem about it. So it's difficult to get a formula to write a poem.
Yes. It's also interesting that it seems like as a form of escapism you're doing the poetry, but I think sometimes I think quite often I have days where if I've been doing programming, I want to go and do something else rather than think about programming. So it's just interesting that you're escaping, but you're still staying within the same area, really.
Indeed, yes. It's good to be able to get away from it in that sense and make it light. Not always, but if you want to write a poem that makes light of it, that can also be a creative process, because I've always found developing software to be very creative. And as I've said, I covered there, it's both an engineering discipline. You can do all sorts of things following good engineering rules, but you can also bring art and craft into it as well. And poetry can sort of help in that regard, I think.
Dinesh.
Yes. I was just kind of you mentioned about it runs on my computer but doesn't run on yours.
Yes.
That the solution for that is a container engine, running it on a container engine. That's what is the solution for that. So basically, if you run it on a container engine, then it runs everywhere. You just have to run the container engine. Yes.
Yes. I agree. And those sort of the build engines that I've used, automatic build engines, would often spin up a virtual machine. You've configured it, what hardware you want, what OS you want, what attached drives, what operating system, what whether you want Tomcat or what version, and it'll deploy everything. And so it's reproducible, because quite often years ago it was a big problem I found with especially Windows development, say in the 90s and the early 2000s. You had they called it DLL hell, because you could have DLLs with different versions, and then you'd have a version on your computer, and the software would work perfectly, and you put it on a user's or a test machine, and it wouldn't. It'd bloody crash, and it's very, very difficult to work out what was happening.
Yes. In fact, when Java came out, they thought it would fix everything and everybody can run a Java program and it will run on any computer. But that was never the case, especially on Windows.
Yes.
Yeah. Toby.
Oh, hello. Yeah, thanks very much, Paul. It's a great way of explaining some of the issues, to putting it into a poem. My take on it runs on my computer is the work I do. It means taking hardware from my bench behind me, where it always runs, to a farm where, it doesn't run. And then you find, of course, it's to do with connections and it's to do with wires breaking. And then you've got it running on the test rig at the farm, and then you put it on a tractor, and then it suddenly doesn't work again. And so I always say that you've got to test it in every possible environment, because the environment that we work in agriculture, and obviously you've worked in it most of your life too, is that wires break, things get chewed, Wi-Fi connections are minimal, 4G.
Things get wet.
Yeah, there's rain, there's slurry, there's organic. We used to get stuff delivered to us saying, this is military spec. And then you realise that a military spec only has to last about 3 days of a battle, and then it's going to be thrown away.
Yeah.
Whereas the farmer wants it to run for 20 years and cost peanuts. So
yes.
So those are the challenges. I have to admit, I tend to work on a 2-hour time window, because if you've set yourself a sensible problem, if it's not beginning to come together after 2 hours, you've probably gone up a wrong tree somewhere, and you're trying to get the language to do something that it's not allowed to do. I mean, I've made the transfer from Java to Python, and sometimes the syntax is so sparse. It kind of, what you mean to say there's a missing colon, and that's the end of the program, sort of thing. So those are the issues that I come across when I'm trying to do debugging. But occasionally I've taken delivery of code from subcontractors, which is totally uncommented and undocumented, with variables which are meaningless to anyone not who hasn't actually written the code. And I particularly remember one batch with something like 30 files of interlinked Python code. It was just impossible. I just had to say, I don't know who this guy thinks he is, but this is unusable. And yet the people who were promoting him said, oh, he's a brilliant programmer. It's always brilliant. It really works. And then he went on holiday and nothing ever worked after that.
Yeah.
Anyway, those are my comments, but it's great to take it through and see, yes, everybody has these kinds of problems and has to deal with them.
Well, it's one of the things you should be writing code, not for the machine, but for another human. That should be the target audience. And quite often programmers don't do that. They understand it themselves, but they don't think about the next person who's got to come along and change it.
If I'm not careful, I can't read my code from 3 months ago unless I've
Indeed.
commented and documented it.
Yeah.
Yeah. Jeff, I see you got your hand up there.
Yeah, thanks, John. Yeah, I'm just looking at sorry, Paul, it might be a question for Dinesh as much as anything. Examples of a container engine. What are you thinking there? I would be looking to replace my all user simulated real test environment with maybe a container engine. What's in the Windows world? What examples would you choose?
I think you're right. I think Dinesh ought to answer that one. Do you mind, Dinesh?
So I think it sounds like you've been there, done that, Paul, but it was Dinesh that.
Yeah.
Yes. What we have here in terms of container engines is mostly using Docker containers. So that's the most popular container engine out there. And so, what they write their code on, and they put it on a Docker container engine. And when Docker came out first, that was the kind of solutions, and they would use a Docker swarm, where you would have multiple containers running in a swarm, basically, and they would be talking to each other. So the programs that are written are actually sort of ported onto the container, copied onto the container, and run on the container as an executable. So that was the first simpler solution. But then people found that is not industrial scale or enterprise scale. Then most of these solutions are in the cloud. You have container services, which is a more robust solution that is provided on the cloud by some of the major cloud providers. And then if you want something even more robust and more secure and resilient and highly available, then you get a Kubernetes. And even that's provided on the cloud or on-prem as well. You can put it on a tin box and cluster it, and you put your programs which you write. So this is the solutions now most big organizations are using.
Okay.
Yeah.
Okay, gives me an idea. All right. Thanks.
Thanks, Dinesh.
Martin, I see you put your hand back up.
Yes. I mean, obviously, Paul, just to thank you for reading some of the poems to us and explaining them, and it's enjoyable hearing you do that. I was wondering whether in the process of compiling the poems, you have actually then had any extra insights into either your programming or programming generally, which you've then been able to apply back to your work.
Oh, I wish I had, but the problem is that I haven't done a lot of coding recently. My last contract was as an architect, and I did do some programming. I wrote some prototypes in C#, but I haven't in recent years. I haven't done a massive amount of programming, so I'm a bit rusty, I think. So I don't think anything that I wrote in poetry would help improve my programming at this stage.
Yeah, so it's more really just a reflection on things that have happened, which is still interesting in itself. Thanks.
It was interesting, Paul, been saying about keeping your code simple. And I know Toby was saying, code that we wrote 3 months ago, we look at and we go, what the hell was I thinking? And having been a on-call support programmer at 2 a.m. in the morning, when you're having to look at somebody's code that was probably written 5 years ago, and you just look and you think, oh my God, and you don't know why, what, how, and you've only got like 2 hours to fix it. So keeping your code looking pretty in some ways, the art of coding, as opposed to the science of it. If your code looks appealing, and we've spoken about that before,
Yeah,
it makes things, it just seems to make things much easier to understand, more readable, more functional, and just, yes, a pleasure to work on, rather than pulling your hair out going, why is this?
and that comes down to often down to the code reviews as well, because if you're in a gated system where before, say, the branch can, the feature branch can be committed to the main branch, you have to go through a code review. Then your code reviewers will look at it and see if they understand it. And if they are not happy with it, it's their duty then to come back to you and say, you need to change this, you need to express this in a different way. So that stuff that hits the main branch is simple and easy to read, and is, as I say, compelling.
Yeah, wonderful. Jeff, I see you got your hand. Is that still up, or you got another question?
Another question, yeah. It's actually a follow-on from the one of the previous questions, insights. One of the challenges I have is I work with a lot of engineers, and they're not the most interpersonal. Some managers are not necessarily particularly good at managing people. Paul, have you got examples of when you've read poetry and presented some of these philosophical ideas to managers and other programmers, do they get some insight into what it's all about?
I haven't had the pleasure of that, I'm afraid. I did.
No.
I my last contract, I did give a book to a chap who was he was the head of architecture at the time, and he sent me an email. So he thought the book was great, very interesting. But whether it had any influence on him or not, I don't know.
Okay, I would imagine it does influence people, to be quite honest.
Something that you did raise, Paul, and I just wondered what your thoughts are, well, and others here. Obviously, with the post office inquiry scandal, which is ongoing at the moment, do you think that it has damaged our profession?
My view is we software development hasn't looked good under this, and it's funny enough, going back to the culture. I think that, as I said, one of my points was that the culture of the organization. I read somewhere that when it was still with ICL before Fujitsu bought them out, and they were looking at doing this project for the post office, and one of the lead developers said this code is not fit for purpose, and we need to start from scratch. And the manager said, no, we can't do that, we've got to reuse it. Now, one thing that came up today was the responsibility for the quality of the code. Now, so there was lots of different areas. they had a third-party report done. This wasn't Second Sight because they were concentrating on the accounting side, but they had another chap to look at the quality of the code, and he said it's absolutely appalling. He said the level of quality is extremely poor. It's not fit for purpose. None of it's unit tested, so you can't. He said even you can't understand it, and you can't test that this is going to work, and yet they're convicting people left, right, and over 900 people on poor quality stuff. And
Yeah, Jeff, you got your hand up again.
Yeah, I'm actually responding to this. I'll make a couple of points with regard to this. I've worked in different size organizations. I'm now working in a big organization. It's very difficult as a technologist. I try to look after the quality of what I do. It's actually very difficult in a corporate environment to take responsibility sometimes. The corporate environment, as they get bigger, kill off the opportunities.
yes, quite often that's the case.
And so
yeah.
there's some very fundamental problems in the way that we operate our corporate machinery and the way we pay people bonuses, for example. With regard to the second point I would make, this is our moment. Yes, it's desperately awful that 900 people have been put through trauma, and some have lost their lives, actually, as
Yes.
I understand it. It's terrible, but it's going to save people's lives in the future. This is our moment as a profession. I've been saying for years, I used to work on antivirus software, and my argument was quality not good enough. We need to have another little go at this. And the sort of response I got back from senior management was, who's going to die? But it was only antivirus software. One of the discussions I'd been having was about our antivirus software crashing and who's going to die. So it's very real. And I think the post office inquiry hopefully will escalate the importance to the corporate machinery out there that we need to actually get this software right now. You've got Teslas flying around the roads that are capable of killing people, driven by software. We all know it's important. We've all tried our best, but it's getting very real now. It has a massive impact on people's lives. So it's our moment as professionals to grab it.
Dinesh.
That's great. That sounds that's doing a 180 on me. Thank you.
There was a lot of discussion about this in the BCS community forum, the British Computer Society, and what was reported there by multiple users is that the Computer Weekly reported this, and BCS just didn't comment about it. And then only later on, when this blew up, did BCS actually follow the herd and made an official response about it. But initially, it was just mum. It didn't focus on sort of software testing or verify. And Fujitsu is basically a publicly owned company, ICL, and the post office is a part of the government again. So, yeah.
There's your corporate machinery again. We need to focus. Quality needs to be a costed-in deliverable, real cost.
Indeed.
My argument as a software quality engineer is I'm actually trying to save you money here.
Yes.
I'm not.
There's a saying that quality costs nothing.
Yep. Yes, that's a good one. Yeah, I like that one. Good quality costs nothing.
Right, I can see Luke with his hand up there. Off you go, Luke. Oh, no.
Okay, hi everyone. So I didn't know what expecting when I saw the title of the presentation, but I'm very happy about the discussion and how, first, the poem ring some bells and bring me memories on the situation that I live or I was involved in. And it was very, very interesting. I really like the approach that you bring after that to the discussion on real problem of developer. I will raise now a point that may be worth to think here. we are talking about software, and maybe we should stop talking about software, and we should stop talking about application, because all your code and all the library was developed with some objective in mind. But when you develop an application, you will assemble your code, and the quality will depend of the objective of the application. When we talk about functional requirement or non-functional requirement, and we can explode that. I hate when we divide just into some code. If you put too much time on it, it will cost too much. So when you say quality is free, it's not really true, because you pay the developer and have to be debug and go further. You will have an impact. And on the other hand, depending of what you want to develop, you may worth it. So if I develop, and I don't want to go into the post office because I don't know everything about that, but if we go, it's a simple example. If I develop a code for home entertainment, or if I develop a code for a nuclear power plant, for sure the quality of the code will be not evaluated in the same way, and the cost and the impact will be different. But if you just focus on the software level, the component you're coding, the developer not always know where the code will be used and how it will be developed. So a thinking has to be done here, okay, to bring a vision to the developer. Stop talking about developer, maybe talking about engineer or architect, because at the end, an application is a type of system. So we are generating system. We are conceptualizing or concepting, designing system, and you may use open source. You can use your own course. You can use closed source. You can have libraries, a lot of things, and we don't develop everything anymore. So even the choice of your library will have an impact depending of what is the focus and the purpose of the system or the application you want to develop. And I'm not going in all the tests, the environment, and everything you bring here today, because everything was there and important, but we're missing a global vision. And after that, to be able to pinpoint where are the key elements that have to be under scrutiny when we develop an application. So it was just to continue the discussion for maybe the next presentation. Thank you very much. It was very interesting.
Thank you.
Thank you, Luke. Toby.
Well, just commenting on Luke, what you just said is that we don't appear to do risk assessments for, and I know everybody hates the concept, it sounds like management bullshit, but I think probably when they were doing the post office software, they were thinking, well, it's only replacing paper systems, and they weren't even thinking that the impact would be people going bankrupt, being accused of crimes that they hadn't committed, and so on. I mean, when we do our projects in agriculture, we always are looking at what happens if we get it wrong. And I'll give you an example. Is there are systems now, robot systems for planting crops at 1 centimeter precision, which are entirely based on GPS. That means that if there's any problem with the GPS, the system could come down and just hoe out the first machine sows the seed in precise locations. Other machines come along and hoe between the rows to kill off the weeds. You could end up wiping out entire crops and entire systems. I doubt anybody's really done a risk assessment on that. I keep banging on about it at the Royal Academy of Engineering, because we're supposed to be doing some future proofing of infrastructure. Everybody assumes that GPS good enough within 1 meter is good enough, but in agriculture we want it down to 1 centimeter or even sub-centimeter levels for some people. So I think we need to do, as Luke was saying, we need to do a full level. What's the effect of this application going wrong? And I'm sure the pioneers of aviation and railway systems, they were risking their own lives, but actually with software, we're risking lives of people who may be many stages away from us in maybe 10 or 20 years time, and that has to be thought through.
A very good point.
Martin.
Yes, I mean, obviously I agree with the general point. I think though with the post office situation, from my understanding, from what I've read and heard, while it may be that maybe from the programmer's point of view, they may have just thought, oh, this is we're just converting a paper system to a computer system. I think from the post office's point of view, the manual system had provided very good control from the point of view of a sub postmaster, because they would have to write out these complicated paper spreadsheets every evening, but at least they had full visibility of what was happening at their branch. But the post office couldn't see that, and so I think they were a bit suspicious about what could be the potential for fraud. And so I think that one of the benefits of converting to a computer system was that they could then see everything, and in the mind of people who were being suspicious, they could then catch the offenders, because they could then see. So perhaps that suspicious mindset may have contributed to all those prosecutions. But I think then the lesson for us as programmers, it's not just finding out about what the program has to do, but perhaps if it's business analysts finding out what's happening, or if it's us as programmers, it's understanding the wider business context. And obviously one of the things here was that, which some people within the post office don't seem to have been aware of at the time, was that the post office was using was the whole business of prosecutions, and that the contract with sub postmasters meant that they were liable for any of these losses. So for us as programmers, I think understanding the wider business context in which our programs will operate, I think is something that is good to do, not just our little box of the program we've been asked to change.
Well, thank you very much, everyone. Thank you, Paul. I think we've had a very interesting discussion, and I should have another go at, just a quick plug, at reading Paul's book again.
Thank you, John.
Available on Amazon.